Hey everybody, thanks for joining me. Today we're going to talk about what we call complex fractions. So go ahead and get your notes ready, get yourself all set up. We have 3 examples to work through. And let me first say that when you see the word complex, you might be thinking about complex numbers, like numbers that are related to the square root of -1. However, in this context, that's not what we mean by complex. Maybe the word complicated would make more sense. These are complicated fractions. They have fractions inside fractions. So they are rational expressions which contain rational expressions inside them. Let's work through how to simplify them. And there's a couple different approaches we could take. So let's take a look at number 1. You might want to pause the video so you can write it down. So one approach, and this is not my approach, but one approach that would be perfectly fine would be if you wanted to get a common denominator for your 2 fractions on the top. So you could get those to both have a denominator of 6, and then you could get a common denominator for your 2 fractions on the bottom, and those would have a common denominator of 10, and then you could combine the top fractions and combine the bottom fractions. You would have a fraction divided by fraction, and then you could change it to multiplying by the reciprocal, and that is all perfectly fine. But I have another way that I think will work a little bit more efficiently and will work nicely with more complicated problems as well. So what I'm going to do is I'm going to take a look at I'm going to call them the little fractions or the small fractions. See all the inside fractions. Look at all their denominators. We have a denominator of 6, we have a denominator of 3, we have a denominator of 5, and we have a denominator of 10. What is the least common multiple of all 4 of those numbers? What number do they all divide into? That would be 30, right? So I'm going to take 30 and I'm going to multiply the top and the bottom of this fraction by 30. So that's going to be my special form of 1, 30 over 30. Now, maybe it will work out more nicely for you if you actually think of it as 30 over 1 over 30 over 1. And you'll see why you might want to write it that way in just a second. Still a special form of 1, it just looks a little different. If you write it this way, you can kind of see how things are lining up, like numerators are lining up and denominators are lining up, both on the top and the bottom. So that's kind of nice. That way you can keep track of what you're doing. Let's get rid of those. Okay, so now what we're going to do is distribute the 30 from the top among both terms and distribute the 30 from the bottom among both terms. So what do we get? We get 30 times x over 6, and the 30 over 6 reduces to 5, so we get 5x minus, now we have 30 times x over 3, and the 30 over 3 reduces to 10, so we have 10x. Boom, no more fractions in the numerator. Now let's do that with the denominator. We're going to multiply 30 by x over 5, and the 30 over 5 reduces to 6, so we have 6x minus, and we're going to multiply 30 by 7 over 10, and the 30 over 10 reduces to 3, so we have 7 times 3, 21. No more fractions in the denominator. They all went away in one fell swoop because we used 30, which helped us get rid of all 4 denominators. Now we can still simplify this expression. 5x minus 10x is negative 5x, and 6x minus 21, we could factor a 3 out of that, but it's not going to do us any good because there's no factor of 3 in the numerator, so we could just leave it like this. So it would not be considered simplified to have a fraction inside a fraction. Now we no longer have a fraction inside our fraction. Let's take a look at number 2. Of course, we have to kick up the level of difficulty just a little bit. So in the previous problem, we had numerical denominators. Now we have algebraic denominators. That's okay. We're going to do the same thing in theory, same thing. Let's find the common multiple of all of our denominators. So we have a denominator of x plus 5. We have another denominator of x plus 5, so that's cool. Same thing twice. And now we have a denominator of x minus 3. So Our least common multiple of those will have a factor of x minus 3 and a factor of x plus 5. I'm going to write that over 1 just to keep everything lined up nicely, and then same thing on the bottom. So this is our special form of 1 that we're multiplying by. You don't have to write the ones, but I just like how it lines up everything for me. Okay, now we're going to do what we did on problem number 1, which was multiply the numerator by this new thing and multiply the denominator by this new thing. Okay, so we multiply the numerator by it, and what's going to happen is the x plus 5s will cancel. There's one on the top, there's one on the bottom. This is one time when I might actually cross it out, but you'll notice if you look back at my previous problem, I didn't cross things out. Like when I had the 30 and the 6, I didn't do that, and that's because I needed to still use the 30 for the next fraction, and I didn't want to forget about that. So just be real careful when you're crossing things out. If you have to use it again, when you cross it out, you might forget to use it again. Okay, so moving on. Now the numerator is 3 times the quantity x minus 3. Now let's work on the denominator. So we're going to take this new thing we're multiplying by, x minus 3 times x minus 5 plus 5. We're going to multiply it by the first fraction. The x minus 3's are going to cancel. We have one on the top, one on the bottom, but I'm not crossing it out for reasons I just explained. And what I have left would be the 2 and the x plus 5. Then we have the second fraction. Multiply the x minus 3 times the x plus 5 by the second fraction, and the x plus 5's will cancel, and what we have left is x minus 3. Okay, now what we have is not finished, but it doesn't have any small fractions left in it, so we have made great progress. Now let's see what we can do to simplify the numerator. How about if we distribute the 3? That may or may not be a good idea if we're about to factor it later. We don't know, we'll see. Let's distribute the 2 on the bottom, so 2x plus 10, and then we have the x minus 3, and let's go ahead and combine the like terms. On the bottom, we get 3x plus 7. So 3x minus 9 on the top, 3x plus 7 on the bottom. Okay, here's a trick question, or a tricky question. Can I just cancel the 3x from the top and the bottom? Can I? Oh, you said that very loudly. I'm glad you know that that is a big no. Thank you for shouting that at me. I'm glad we're enthusiastic about that. Remember, you cannot cancel unless you have factors. And 3x and 9 are terms, not factors. When they're connected with a plus or a minus sign, same thing on the bottom, 3x and 7 connected with a plus or a minus sign. They are not factors, they are terms. If you cancel part of it without taking the whole thing into account, you're not going to have an equivalent expression. So this is our answer. Let's box it and move on. Number 3. Okay, here we go. Third and final example. Now we have small fractions inside our big fraction, so we're going to do the same thing conceptually. However, some of our denominators need to be factored before we can figure out what to do. So I'm going to rewrite this with factored denominators. For the first denominator, I'm going to factor out a 3, and that will leave x squared minus 1, and that can be factored into x plus 1 times x minus 1. You can do that in a couple of steps if you want to. And then on the bottom we have the first fraction. It's just fine the way it is. And then we're going to factor the denominator of the second fraction on the bottom, and that would factor into x minus 4 times x plus 1. Okay. So now let's figure out what we need to multiply by. What is our special form of 1? Well, we need an x plus 1 for that one, and that one, and that one. So we're going to have an x plus 1. We need an x minus 4 for that one, so we're going to have an x minus 4. And we need an x minus 1 for that one, so we're going to have an x minus 1. And that's all over 1, and same thing on the bottom. It doesn't matter what order you write those in. Okay, now let's multiply the numerator of our big fraction, our complex fraction, by this new thing. So, since there's only one fraction on the numerator, you can go ahead and show canceling of things. So we can cancel the x plus 1s, and we can cancel the x minus 1s. And then what do we have left? We have, oh, notice a 3. I completely forgot the 3. Let's also multiply by 3 there. That was a close call. You were probably saying something about that and I didn't hear you. Okay. And let's cancel that 3. So what do we have now? For the numerator, all we have left is x minus 4. Okay. Now the denominator, let's work on the first fraction multiplied by all 4 of those factors. The x plus 1 is going to cancel. So we're still going to have the 5. We're still going to have the 3 and the x plus 1 and the x minus 4. So we have 15 times x minus 4 times x minus 1 minus, now let's work on the second one, all that times the second fraction. On the bottom we have an x minus 4, so that will cancel with the x minus 4. On the bottom we have an x plus 1, that will cancel with the x plus 1. So we're still going to have the x minus 1, we're still going to have the 3, and we still have the x plus 4 from the top. So 3 times x plus 4 times x minus 1. Okay, let's simplify this. Let's work on simplifying this denominator. So for the first part of the denominator, let's go ahead and multiply these binomials together and then multiply them by 15. So we have x squared times 15. Insides and outsides add to minus 5x. Multiply that by 15. Last, multiply to be 4. Multiply that by 15. And then we're going to FOIL the x plus 4 times the x minus 1, and then multiply those by negative 3. So we have x squared times negative 3. The inside's 4x, the outside's negative 1x, that adds to 3x. Multiply that by negative 3. And then the last, we get negative 4, multiply that by negative 3. Now let's combine our like terms. So we have 12x squared minus 84x plus 72. Okay, so maybe we can factor that. Well, definitely we can factor that because we can factor out a 12, but maybe there will be a factor that cancels with the x minus 4 on the top. We don't know until we try. So let's figure it out. Let's factor out the 12. That leaves us with 8x minus 7x plus 6. Okay. And then, does that factor? Looks like it does. We get x minus 6 times x minus 1. But that's great that it factored, but nothing cancels. Hopefully I didn't make a mistake on the top. Okay. So, for your final answer, you have several forms you could leave it in. As long as we're here and we figured out there's nothing more we can do, why not just put a box around that and call that the answer? But there's also nothing wrong with having the multiplied out form as your answer. This could be your answer. What you don't want to do is forget about factoring it out, because there may be a problem where when you factor it out, you do cancel something. Okay, great. So your homework is to do 5 problems, numbers 31 through 35 all, on page 587. Remember to check your answers. I have posted them all, and if you have questions, please let me know. Thanks, everybody.